All right, so we're going to continue 3.5e, part 3 of solving rational equations, which we're talking about solving rational equations. So we're going to do this by hand, and then we're going to use the calculator to check it and show why it's super important that you're checking your answers. Bless me. All right, so notice here how on each side we only have one fraction. So the beauty about this is that because there's only one fraction on each side, we actually can cross multiply. And so we're going to cross multiply 2x times 5x. So 2x times 5x equals, and we're going to cross multiply 5 times x squared minus 5x. Okay, so what I end up here with is 10x squared equals 5x squared minus 25x. Okay, we still want to apply zero property here, so we can solve this, which means that we need to get x by itself. So I'm going to subtract 5x squared, and I'm going to add 25x. That's going to leave me with 5x squared plus 25x equals 0. Okay, in order to solve this, I need a factor, so I can use the zero property. So I'm going to factor. I'm going to factor out 5x, and I'm left with x plus 5 equals 0. Okay, so we are left with 5x equals 0 and x plus 5 equals 0. So we end up with that x can equal 0 and x can equal -5. Okay, now this is an example of why it's really important that you go back and check your possible solutions. Okay, if we keep in mind also our domain restriction, so when I come back to this original problem, I know that x cannot equal 0. So that represents the fact that this is what we call an extraneous solution. So this isn't my real solution. My real solution is -5. Okay, x equals 0 is extraneous. It comes out mathematically when I'm solving, but when I plug it back into the original, it will not work because in the original, x cannot equal 0. Okay, so next we're going to use a calculator and show you how to solve this in a calculator. So notice on my right-hand side, on my left-hand side, I have 2x. So I'm going to protect my numerator. 2x divided by 5 is just a number. And then I'm going to do on the right-hand side, I'm going to put in y2. So protect my numerator, x squared minus 5x divided by, parentheses, protecting my denominator, 5x, because it's not just a number. And what I'm going to do is I'm going to graph and see what happens. So, oh, thank you. So notice it graphs the first function, then it graphs the second function. Please ignore that bell. So when it graphs, I can clearly see that they intersect at one point. Notice how at x equals 0, they do not intersect. So that's another example of why this is an extraneous solution. I can also click second graph and go to the table to see if I can find that point of intersection. If you look here at 0, one of the functions is defined at 0, but the other one has an error. Remember, it has that removable discontinuity of there being a hole at 0. But I go up to where it was looking like they were intersecting, and notice at -5, I get -2 and -2. So that is why -5 is my real solution. We're gonna go back to the graph. From the graph, you also can find the point of intersection by pressing second, trace, and intersect. You wanna use your little spider to crawl as close as possible to the intersection, the point of intersection. Once you're close to that point of intersection, you're gonna hit enter 3 times. 1, 2, 3. And I hit enter and it says -5. So when x equals -5, both equations equal -2. Okay, so that's another way of using the calculator to help us prove our point. All right. So now looking at the last one, again, we can set up using multiplication so we can cross multiply. And we end up with 8 times x minus 1 times x minus 2 equals 4 times x squared minus 4. Okay, being mindful of what we have here, we know that what x cannot equal. We know that x cannot equal +2, and we know that x cannot equal -2 based on our denominators, difference of 2 squares, and that factor is already done. All right, so we're going to go forth and multiply. So I'm going to distribute, and I get 8 times x squared minus 2x minus 1x plus 2 equals 4x squared minus 16. Okay, I'm going to distribute the 8. So I get 8x squared, a negative 2 and a negative 1 makes negative 3. Negative 3 times 8 makes negative 24x plus 16 equals 4x squared minus 16. Now I'm going to combine like terms. So by combining like terms, I'm going to subtract 4x squared and add 16. So when I do that, I'm going to be left with 4x squared minus 24x plus 32 equals 0. Okay, so before I do anything, I can factor out 4. I can find a GCF of 4. So I can divide everything by 4 because that's my greatest common factor. That's going to give me 4x squared minus 6x plus 8 equals 0. So I'm asking myself what multiplies to give me 8, but adds to give me negative 6. So my factors would be x minus 4 times x minus 2 equals 0. And we don't forget to bring down our GCF. So my two possible solutions are x equals 4 and x equals 2. Now, what did we say about 2's in the beginning? These are our restrictions, right? X cannot equal 2 and x cannot equal negative 2. So therefore, x equals 4 is our real solution and x equals 2 is an extraneous solution. Okay, so we got to be mindful of this when we are working, and that's also why it's super important for you to check and plug in. Could you have used a calculator and found the intersection by using y1 and y2? Why, yes, you can. Just make sure when you're plugging into the calculator that you're protecting your numerators, protecting your denominators. Okay, otherwise your graph will be messed up. All right, that concludes 3.5E, which concludes Unit 3.5. Please prepare for your test.